Jai Hind everyone. My name is Aastha Sharma from Computer Science and Engineering Department at Ajay Kumar Garg Engineering College. My subject is operating system, and today I will discuss about the introduction of the operating system and what are the histories, what are the evolution, and what are the functions, and what are the classification of the operating system. As you can see this, it is the program to manage the computer hardware. Basically, we made some type of interface that we can communicate easily with the hardware. Like some type of applications are there so that we can interact with the hardware also. It also provides the applications program which act as an intermediate level between the computer and the hardware. Basically, we means that we made a communication between the hardware and the application. Hardware are the CPUs, memories, RAM, keyboards, etc. These are the hardware. And what are the applications like Google and some type of interface we need to communicate in this? We need the operating system. It is also designed in such a way that provide the environment to communicate with the hardware. For example, we have Microsoft, like for Windows we have, and for Linux we have Ubuntu, and for the iPhones we have the iPhone Mac OS operating system. These are the few examples of the operating system which we used in a day-to-day life. Next, I will talk about what are the operating system do. So basically, it controls the hardware and coordinate all the resources among the various applications programs. Like it provides the proper use of the resources. It also provides the operations for the computers to operate all the system. Like hardware, we have CPU, memory, input-output devices, computing resources of the system. And the application program we have the users can access with the help of the application. We have the word, processors, compiler, web browsers. These are the resources which the users can use. And for example, we have to operate all the system, we have the government, like it performs the no useful functions by itself, and it also provides an environment within which the programs can execute and fulfill all the schemes and all the resources with the help of the coordination. Next, I will talk about the operating system. Operating system works on 3 levels. First one is the user level, second one is the system level, and the operating system, what it can do. The focus area at the user level, we have the user interact and the experience, which means how the user can easily access to the resources available in the application level. System view, we have some internal system operation and resources. Internal system are like process scheduling, like file scheduling, input and output resources we need. And for what the operating system is do, like management of the hardware and the software resources. The audience we have in the user view, we have the end users, we have the people interacting with the systems and interacting with the software. In the system view, we have technician, system designer, and the administration. And we have in this the system software applications and the responsible to the hardware and the resources we have. Next, we have the components. We have the user interface applications. We have in system view, we have the hardware and the software architecture. In operating system, we have the component like the kernel. Kernel are the system or the software which is the main core part that can execute all the resources with the help of the hardware operating system. Now we have the device driver, type of secondary memory we will use to executing the resources. Now the example of the user view level is we have application of the website, and for the example of the system view level, we have the resource management like the architecture which will be used to execute all the commands. We execute all the resources as per the user's needs. And for the operating system we use like Windows, Linux, Mac OS to operate all the resources available as per the users. Next, we have operating system architecture. The operating system architecture have several segments in which it will work according to that. The strategy we use for the components, we use the kernel. Kernel, it is the system of the operating system which execute all the hardware resources. We have some type of the operating system structure, like we have simple structure, second we have monolithic structure, we have third one is microkernel structure, then we have hybrid kernel structure and layered structure. Simple structure is like the simple which we use with the help of the user's needs and to execute all the command. Monolithic structure provides some type of functionality like process management, file management, and some type of input output operations. Microkernel structure provides some type of in user level operation and some type of the kernel level operations. Hybrid kernel structures provide the both combination of the user and the kernel way to execute and fulfill all the resources as per their user need. And layered structure, we have some type of layers like layer 0, layer 1, layer n. It is a type of the interface by which we can execute all the resources. Let's talk about the simple structure. Simple structure operating system which we have, it is well defined structure, it is very simple and it is very small, but it is also limited. Because it is limited because it executes the some functionality, some user level application. The second one is like the user level of functionality are not well separated. Like if you want to execute the one operation at the user level, it can coordinate as per the time to execute the resources and give you the output. For example, like we have MacDOS. It is the one of the best example to execute on the basis of the simple structure. It is also able to access the basic input output routine, and here are the some drawbacks of the simple structure, like it executes the one time of the operation, but it also crashes if the one user's program fails. Next, I will talk about the monolithic structure. Monolithic structure, it is the type of the architecture where the entire operating system is implemented as a single large process in kernel mode. Again, the kernel mode is like that which execute all the processing or which can execute the operating system handles like file management, networking subsystem, memory management, process management, and some type of the secondary memory which will use to store the location of the particular file to execute at the user level. And we have some the essential operating system services like the process management, memory management, file management to combined in a single code block. As you can see this in the architecture, we have some type of the unprivileged mode. Unprivileged mode is like which will be not used, but it can access as per the user needs. Some type of the application. For example, application 1, we have some type of word processing system. Application 2, I want the PDF access, and application 3, I want to access the web application. Then for all these 3 users application, it can coordinate at the kernel level like file management, networking system, memory management, and process management to access the hardware level, like to access the hardware code of the generation. Next, I will talk about the microkernel structure. Microkernel structure, it is the type of the operating system which remove all the non-essential component from the kernel and implement them as a system and the user programs. Like it can execute at the user level application. Suppose the user can need to access the particular file to access the particular application or to give the commands to print so at that time it can remove all the essential component which is working at the backend and to execute the one particular file or to execute the one user's programs to give the output. So microkernel, it remove all the non-essential component from the kernel basis. So earlier I said like kernel basis we use the file operating system, the management system. So it remove all the non-essential component which is not working at the kernel level and execute as the user level program. This also result in smaller kernel that called the microkernel. Like in kernel we also have the small kernel which execute the program at the user level basis. Like the advantage of this application, we have some new services which can be added as the user space level and which does not require the kernel storage purposes. It also one of the most secure and reliable processes. One of the best example is the Mac OS is the best example that can execute on the basis of the microkernel structure. Next, I will talk about the hybrid structure. It is the combination of the user and the kernel mode to access the hardware level hardware layer. Like user mode, we have some type of the application like in user mode. Like if I talk about in the simple we have only to access the application program. And if I talk about in the monolithic, we have some type of similar application we used in unprivileged mode. But in microkernel, we remove all the applications, and in hybrid architecture, we have some type of user mode like process management, file management, input output management at the user mode. And in the kernel mode, what we have, some type of device storage like secondary memory, primary and the secondary memory we have, like we called the device driver. And for second purposes we use in the kernel mode, we have low level address space management, and for the low level process management we have to access the particular interprocess or makes the communication between the user and the hardware. The main process to for using the operating system is to make the communication between the user and the hardware. So here are the some type of the structures we used for the user need purposes. Then we have last the layered structure. Layered structure, it can be broken into the pieces and can retain much more control over the system. Like we have layer 0, which can access the hardware layer, and layer 1 we have some type of kernel or some type of storage microkernel we use in the layer 1, and layer n as the user interface, like the user application or the user need can access or to communicate for on the basis of the intermediate level between the user and the hardware. So in this we have the user operating system is broken into the number of layers. We call the layers, we call the levels, and bottom 0 layer is called the hardware, and the topmost layer we call the user interface, or we call the user level communication between the user and the hardware. Now, what are the operating system and what can be the responsibility can be handled by the operating system? As I earlier told you, it makes the communication between the user and the hardware. So, according to this, it control all the computer resources to manage input and output operation. Second, we have it provide the valuable services. It can coordinate your process to the particular system, particular hardware requirement which will use for the earlier processes, computing processes. Third one is that it coordinates the execution of the programs. So one of the best functionality it can coordinate, it can execute on the program level purposes. Then fourth, we have it provides the resource for the user, resource we use for the execution processes. It provides an interface to the user. It means interface, which means it makes the communication between the user and the hardware. Fifth one is like it support the multiple execution code, like it can execute the file management system, multiple execution code, one of the best example, and it can also coordinate the device management also, function management also was there. Next, it monitor the execution of the program and can prevent the errors also. So these are the best responsibility that can be handled by the operating system to execute the one program from the user and the hardware level accesses. Next, if I talk about what are the objectives of the operating system. Number one objective, it is convenient to use. How it is convenient to use? Because it makes the communication between the user and the hardware. As you can see this in the program, the application program, which means the user level accesses, and the hardware level, which means hardware level are like the keyboard, the mouse to access the hardware level programs. Next one is that it is user friendly. How it is user friendly? Because it is used in GUI, which is the graphical user interface, and it also used in the Windows also. Next, third one is that it is easy to access. How it is easy to access? Because it can execute the multiple tasks at the same time. So it has one of the best functionality. It can execute multiple tasks at one time. Next, fourth one is that the management of the resources. How the management of the resources, how you can process the schedule, how you can manage the file, and how you can use the processor management. All these comes in the management of the resources to execute the one resource at the user level and to the hardware level, which means it can makes the communication to process to execute the program from one level to the another level. One level, which means the user level to the hardware level. Next one is that it control and monitor. Again, it can also manage all the hardware resources to run the application smoothly, and it does not gives you the glitching area of the resources. Next one is that fair sharing of resources, which means it can make the proper utilization of the process and schedule to allocate the CPU time and the other resources. So all these are the objectives of the operating system. It is convenient to use, it is user friendly, it is easy to access, it can manage all the resources, it can coordinate and control all the requirement of the user level, and it can share all the resources at a fair level, like it can allocate the CPU at one time to execute your program. Next, I will talk about the operating system features. It has the platform for the application program. Next, it can manage your input and output unit also. It can also perform the multiple tasks. It can also manage your memory and the file at the execution level. Then it's provide the security, and it can also monitor the execution of the user program to prevent the errors. So all these are the features of the operating system. It is kind of similar to the objectives. Next, if I talk about the history of the operating system. So basically, the creation of the operating system is started in the 1956. And in 1956, in which organization is using the operating system is like IBM. IBM is generated the operating system in 1956. And around in 1960, IBM developed some type of operating system series to perform the multiple tasks at the same time. And one of the best example of the IBM in 1960 developed like Unix. Unix is developed to execute the multiple tasks, to coordinate the tasks at the same time. And after that, in 1970s, the Unix become one of the most popular academic circles, and to give the some type of the versions to execute and to coordinate your process at the same time and manage all the process which manage all the process between the user and the hardware. In 1977, Apple also releases their own operating system to execute the multiple tasks at the same time and coordinate all the resources at the execution level. And in 1981, Mac-DOS is also released by the Microsoft to execute the multiple tasks. And in 1980s, the one of the home computer revolution is started to operate the system, and in 1991 Linux is released by the Linus Torvalds, which is used for the operating the system and makes the communication between the user and the hardware. And in 1990s, the Windows, which dominates the laptops and the desktop market, which can also give you the same type of the operating system. And in Windows 95 is also released in the 1995. Unix and Android and OpenShift is released for the makes the communication between the user and the hardware. So all these are the history of the operating system. Few organization is used for their own purposes to perform the multiple tasks at the same time, to coordinates their file, to coordinates the input output operation, to coordinates the file management system, to give you the best output and give you the more flexibility and more reliability during the execution or during the communication between the user and the hardware. Next, if I talk about the evolution of the operating system, as you can see in Unix, in 1960s, the POSIX was released in 1918, the portable operating system standard developed for common architecture. All these operating systems I talked about in the Unix, Linux and Windows and Mac OS, all these four have their own operating system architecture to execute and to coordinate and to make the communication between the user and the hardware for the particular operation, for the particular task. As you can see this in the Android section, the 2008, the modern mobile operating system kernel is used by the Linux kernel, and in 2014 the Samsung is also used, the Samsung Watch is used. Some type of the Red Hat was used by the CentOS, and it also used for the purposes also the Darwin, the Mac OS is also released by their own operating system like Watch OS, TV OS, iPad OS. All these the iOS software I used, and I tell the have their own architecture to perform, to operate or to make the communication between the user and the hardware. The POSIX based Microsoft or IBM, we have the Microsoft Docs, we have the Microsoft Window NT, we have the Microsoft XT also. Like we have Microsoft Docs, we have Microsoft NT, we have Microsoft XP and the Microsoft. All these are the series of the Microsoft to execute and to perform their own operating system. And all these have, like we have the iOS, we have the Android, all these have their, and Unix, all these have their own operating system architecture to perform and to execute their own operating system performance. If I talk about the functions of the operating system, earlier I talked about the operating system, what are the functions. Next I talk about the functions. So all these are the functions of the operating system. Number one, resource management. For example, if you want to execute one of the tasks or one of the operations, so we need some type of resource management to execute and to coordinate all the resources and to give you the valuable output, or you can say that it makes the communication at the resource level from the user and the hardware to execute the program. Then we have process management. If you want to execute one of the process, one of the tasks, you need the process management to execute all of their programs. Then memory management is one of the best functions of the operating system. Then security management, file management, device management, networking management, user interface level, backup and recovery level, virtualization, performance monitoring and system call. All these are the function of the operating system. Suppose if you want to execute one of the tasks or one of the program from the user level and you need to access the hardware level. So all these processes which I have mentioned in the function of the operating system are required to manage the communication between the user and the hardware. Now I talked about the resource management. What are the resource management? So the process to manage all the resources efficiently, like the CPU, the memory, the input-output devices, or some of the other hardware resources you need to run your executive programs at the runtime level. Like we have some of the terminologies in the resource management. Number one, we have the resource allocation. Like resource allocation, which means it defines the process to assigning the valuable resources to process or to execute your program. Next, we have the resource. Like anything you can use in the resource that can execute in a statically or in a dynamically. Statically, which means you required and you give the some specific space to execute, but in dynamically you can change the location of the file. So it depends on the resource management. So it can also work on the basis of the statically and also on the basis of the dynamically. Third one, we have the resource management. Resource management is like to manage the resource efficiently from the user level to the hardware level. Next, we have the process. Fourth terminology is process. Process that you can execute one of the program or the application. It can be executed in the operating system, which means it has their own memory space also. The process you can give at the user level have their own memory space, have their own execution state, and have their own resources to execute in the operating system or execute in the resource level management system in the operating system. Next one, we have the terminologies is like the scheduling. It is the process of determining from multiple number of processes executed at the same time. Like if you want to execute or if you want to execute the task or the job at the same time, then you need the scheduling process. Scheduling, which means it can give you the slot and give you the type of area you can execute and then can perform your task at the user level to the hardware level. Next, we have the deadlock. Deadlock is like to remove some of the errors which can be generated at the resource level management. Next, we have some type of the features or the characteristics are there in the resource management of the operating system. We have the resource scheduling. Like resource scheduling, which means the operating system allocate a available resources to process the requirement or to process or to access the hardware level user like CPU, memory and other resources. Next, we have resource monitoring. Resource monitoring is like we used for the which process or to take the action which can be taken at the same time or causing the deadlock or removing the deadlock area. So we use the resource monitoring. Next, we have resource protection. The operating system can also give you one of the functionality to protect your data from the unauthorized or from the fake access from the user level area. Then we have next is resource sharing. Resource sharing is like to permit many processes like memory and input output to share the resources. Here are the some diagram here, like the application level and the user level we have. Application level is like we have some type of the area is like the system call. System call is like we need some type of the area, we need some type of allocation to monitor, to allocate and to operate the operating system. We use the system call. Suppose one of the process one you give to execute in the operating system level, then it can execute on the basis of the requirement. We need the system call and we need the some type of operating system resource management. Operating system resource management, it can execute your file management, it can execute your processor, how type of processor you need, it can execute the input output operation. All these operation it can be used for the resource management processes. Next, we have the memory management. Memory management, it can manage the allocation and deallocation of the memory, which means allocation. If you need to process or if you need to execute one of the tasks, then you need to allocate the memory for the particular task. And if the task is if the task is completed and you have the output, then you need the deallocation of the memory space. So memory management, it is made up of the large type of the array of the bytes, and it can be used for the fast storage purposes, and it can be also accessed directly by the CPU. And some type of the execution programs can be first loaded in the main memory. So here are the some type of the activities which we used in the memory management, like to keep track of the primary management like allocation and deallocation of the memory. Then second one, we have some type of activities is like operating system can decide the memory accesses, how long it takes to execute one of the particular task, right? So it can also used in the multi-programming purposes also. Next, we have the allocation of the memory to the process when the process can request and request it, executed your program and deallocate at the same time or terminated the area and the process of the input output operation. Here you can see this in the diagram. Like first you need to register what is your the process you can execute or the task you executed. Then it can goes in the sachet, like sachet, it can create the multiple type of the data. Then it can goes in the main memory, then first electronic disk is the first memory. Then it can goes to the magnetic disk, optical disk and magnetic tape, which means it can execute the level wise memory management to execute and to allocate the process to execute at the user level to the hardware level. So it can manage the allocation and the deallocation of the memory at the same time to execute your program and the code. Next, we have the function processor management. Processor management decides in order in which the process can have to be accessed, or it also called the process scheduling. Like if you have some type of the operating system you need to process or you need to perform some type of the task, you need the processor management. Like processor management, it is the process which managing all your computer or all your managing the task at a CPU is used. Like it can involves the creating, the scheduling and terminating of the processes. For example, if you need to execute one of your program, then you need to go to the processor management. Processor management, what do it can create your process, it can schedule your process, and once your process is completed, it can terminate your process. Then we have the keep track of the status of the processes. It can also remove the traffic controller. Like it can also allocate the CPU to process and deallocate the processor once it is completed. How the operating system process can be handled? Once your process is generated, like it can goes in a new phase, then your process getting ready to execute some type of a state, then it can goes to the ready state, then in running state, which means the process can go and running, like executing the task, and if or it can use in the waiting state, then it can waiting state can be assigned to the processor, and when the running state is executed, the some type of the instruction, and after the waiting, the input and output operation can be executed. Now device management is also respective drivers was there, right? Keep track all the devices, connected systems and processes can be used certain devices effectively and efficiently. So these are the file management system, these are the input output management system, and security management is one of the best example. The classification of the operating system, we have the batch operating system where does not can interact computer directly. We have time sharing operating system, the users can to share the computer resources, for example the Android application. We have distributed operating system, we have the example Microsoft Windows Server. We have networking operating system that provide the capability to manage. We have real-time operating system. We have some user level access, multi-level and embedded system which can be used for the makes the communication between the user and the hardware. Thank you and Jai Hind.